This is the problem number 13, which is a little tricky problem. So the problem is, let u1, u2, un be an orthonormal vectors in an inner product space V, and we define the matrix A as this, where Aij is the inner product of ui and uj. We need to find which of the following options are correct. A is symmetric, determinant of A is 1, equal to 1, determinant of A is equal to 0, or A is irreducible. You can pause the video for some time and try to solve the question. Starting with the first statement, whether A is symmetric or not. Here given matrix A is this matrix where Aij is the inner product of ui and uj, and we know that the inner product of ui and uj is equal to the product of uj and ui, because the inner product is symmetric. Okay, because the inner product is symmetric, and hence if we see this term can be written as Aij and this term can be written as Aj. Since Aij is equal to Aji, which is the characteristic of symmetric matrices, okay, and hence we can say that the matrix A is symmetric matrices. Since Aij equal to Aj, hence the matrix A is symmetric. Now we need to find the determinant of A. If we see the matrix A is taking all the combination of Aij. Okay, if we take A11, then A11 can be written as the inner product of U1 with U1. Okay, similarly we can see A12 can be written as the inner product of U1 with U2, and so on. Okay, but here we can see the U1, U2 dot UN are orthonormal vectors, which means that the inner product of Ui with Uj is 1 only if I equal to j, otherwise this inner product is 0. Okay, using this we get the matrix A, which is, since this is I equal to j, this is 1, all the elements in the row is the row is 0. This is 0. Okay, this is 1, all the other elements in this row is 0, and hence all the diagonal elements are 1 and other than the non-diagonal elements are 0. And hence what we will get is, we will get all the diagonal elements are 1 and non-diagonal elements are 0. This is nothing but just the identity matrix of n dimension, and hence we will get the determinant of A is 1. Okay. Now the next is invertible, since we know that the determinant of A is 1, which is greater than 0, and hence the matrix A is invertible matrix. And hence we will get A is symmetric and determinant of A is 1. This is wrong, A is invertible. Thank you.